Hello, everyone. We'll start in just a few minutes. Welcome, everyone. I'm so excited I get to present at this conference. Thanks for joining us. Okay, let's dive in. This is going to be so much fun. Hi, I'm Rob Richardson. We're going to talk about the definitive deep dive into the .git folder. I've already posted the code online, so you can go to robrich.org, click on presentations. Presentation right here at the top, the definitive deep dive into the .git folder. And here's a link to the code on GitHub there right now. But the of this presentation actually is live demos. So yeah, this is my one and only slide. Let's put that away. Okay. Our task today is to look at every folder, every file inside the .git folder. Now, we're going to look at all of the types of files. We may not look at every single file, but we'll look at all of the types of files in the .git folder. We won't look at all of the commands in Git, but we will look at all of the files in a .git folder. We're going to look at objects, refs, logs, hooks, configuration, temporary files. We'll hit all the things. It's going to be so fun. So right here, I have an empty folder, a completely empty folder. Let's create this as a new Git repository, Git init. When we say Git init, we create this .git folder. Now, if you don't see the .git folder, you can choose to go to View Options and Show Hidden Files. And once you do so, here is that .git folder. Now, this .git folder is the Git repository. So the way to back up a Git repository is to back up this .git folder. Cool. So let's go open up this folder inside of VS Code and start to look at it. Open with code. Okay, the first thing we're going to look at is the objects folder. And right now, the objects folder is empty. Well, it has an info folder and a pack folder, but both of those are empty. Back in objects, let's go create some content in our Git repository. Echo file1 to file1.txt, git add file1, git commit -m file1. Okay, so we've just created a commit in our Git repository. This is perfect. Let's go back into our .git objects folder, and we see we now have 3 folders. Looking at it in VS Code, here's our 3 folders, and each of the files in there is, well, a big binary blob of mess. What is this? Well, this is a zlib compressed content for this git commit. If we were to go look at various mechanisms, we can look at how would we unzip this? How would we deflate this? There's pigz, there's here's a small Python program. You can use Perl to do this. Here's an OpenSSL command that will zlib compress this. Here's a program. I wrote a small node program here called unzipper. And this unzipper just goes and grabs the file, zlib inflates it, and echoes it back to the screen. So whichever command we run, we can cd.git, cd objects. Yep, I'm in the Git dir. Let's unzipper 0b. And when we look at this node, this one happens to be a tree node. The length is 37 bytes. And here's the content of it. This is, still compressed in another way. Let's take a look at another one. Unzipper 5.1. Here's a commit node that 85 bytes. It references a tree node. It references who the author and the committer, who did the commit and who did the push, and then the commit message. That's cool. Unzipper E2. Here is a blob node that is 6 bytes, and here's the contents of the file. So we see we have a commit node that references the tree node here. We have a tree node that references files here, and we have the actual blob content here. This is actually the blob ID, this git hash. Each of these 3 nodes serves a different purpose. We committed one thing, but in that one commit, we referenced the various files, various directories, and we referenced the specific file content. That's cool. There's a tool inside Git to be able to do this as well, where we can say git, actually let's git log, git cat file -t, and let's look at this one, E2129. Cat file -t will yield us the type. In this case, this is a blob. Cool. Git cat file -p E2129 will yield us the contents. So in this blob, we have this file content. Git log, not online, git log one line. Let's go look at the cat file for this. Git cat file -t. This is a commit node. Git cat file -p. And here's the contents of it. It references this tree node. Okay, git cat file -t. What type is this tree node? Well, of course, it's a tree node. Git cat file -p. Here's the contents of that tree node. It says that this file 1.txt blob, referenced by this, is not in any directory. And so we did this before, git cat file -p. Here's the contents of that blob. We have a commit node, we have tree nodes, and we have nodes. Okay, so let's echo, to get out of the Git directory first, echo file 2 to file 2.txt. Do we have any content in our .git folder? We just have those 3 commits. Git add file 2. Have any new content? Yes, a new one. We had E2, we had E, we had 0b, but now we have 5.1. Cat file E5.1. Nope. Let's go view. That would be 5174b. Git cat file -p 5174b. There we go. There's our. Oh, that was the wrong one. It would be really nice if we had a tool where we could kind of browse through all of these commit messages rather than just looking at all of the pieces. I've built an open source project here at github.com/robrich/git explorer. I'll copy this into chat. that is a way of viewing all of these commits. This is two pieces. It's a front-end application written in D3 and a back-end application written in TypeScript. So here inside this application, I'm going to point it to where is that folder that I want to browse, the Git directory, and I'll come here and I'll visualize this. Let's load this back up, and we see we have these 4 nodes. Okay, that's interesting. Clicking on a node, we can see the contents. So here's a blob node, here's a tree node, and here's, well, it'd be nice if we could show the type. So commit are red, tree are blue, blob are green. And let's actually show them like we did before. Let's show some content, and now we can kind of browse through them a little bit easier. That's cool. So when we created file 2 here, we created file 2, but it's just a blob node. It's not really connected to anything. If we wanted to, we could reference it like this, parent-child, where we see this commit, and then we see this tree, we see this blob, and we see this other blob. Now we added it to our staging area, but we haven't committed it yet. Okay, let's commit it. Git commit -m file 2 commit. Now that we've committed it, let's go refresh our graph. Yes, let's show the types. Let's do it in alphabetical. Let's show the tags. Well, actually, let's show it parent-child. That was a cool view. Let's do the lines. Let's show the tags. Okay, so we have this new commit node. Here's our commit. It was done at this date time in this time zone. It was here's the parent node, the one before it. Here's the tree node. This is this tree node right here. And this tree node says that I have file 1 and file 2 in this commit. And they happen to be in these 2 blobs. They're blobs. So I have this file 2 blob and I have this file 1 blob, all referenced by this commit. That's cool. We can start to wander through our commits. We noticed that as we first staged it, we got this commit, or this blob, and then once we committed it, we got the trees and the commits. That's cool. Let's do that again. Let's create a new folder here inside our application. New folder, and let's say echo file1 to folder/file1.txt. Now we already have a file called file1 and it has the exact same content, but it's not in the folder. Let's see what happens. Git add folder file1, git commit -m in a folder. And let's refresh our visualization. Yeah, I want to do it parent-child. I'd like to show the lines, the tags, the types. Okay, so we have this new commit. It references this tree node that says I have 1 file, 1 folder, and 1 tree. This one references this tree node, and this tree node says I have file 1. So we only have 2 blobs in our repository, in spite of the fact that we have 3 files in our working directory. It noticed that this file 1 was identical, and it just referenced it again. That's cool. Okay, so let's come in here and let's modify a file. I want to come into file 2, and I want to change it. Okay, so we've changed file 2. Git add file 2. Now we're adding the changes to file 2. It's not that we're adding file 2 as a tracked file. Git status, we see that it's in our staging area. Perfect. Git commit -m changed file 2. Refreshing our graph, we can see that let's show type, parent-child, lines, tags. We have this new commit that references the new modified file 2. Now here we're referencing this original file 1 and we're referencing the file 1 in a folder, but we're no longer referencing this file 2 because we changed it. Well, now what if I want to amend this commit? Let's come back in here to file 2, and I want to change again. Now, I do want this to be part of this commit. So I'm going to come in here and I'm going to say git add file 2 and git commit -m more changes. And I'm going to say -amend. And by saying amend, now I'm saying I would like to rewrite Git history. I'm amending this previous commit. Now we see that we get a new commit message, git log --1 line. We see we get a new git hash, but let's go refresh our graph. Refresh, show type, parent child, lines, tags. Here's our new modified commit with more changes. It's pointing at this tree node with this modified file 2. But this old commit still exists in our repository, referencing this old blob that still exists. If you commit secrets to source control, even by accident, they are still in your Git history. Git is really good at this. Now, there is a way to prune them out, but it is not permanent and it's not immediate. And so even if you just stage your secrets, you can consider those secrets lost. They are in your Git repository. This one eventually will get cleaned up because no branches are pointing at it. But this one, with the modified files, will be the one that we transmit. Okay, so have this .git folder. It has objects, and each of those objects, wow, they're starting to get to be quite a few things. Now, in time, I may want to start to pack these together smaller. I can say git gc. Now, gc is run automatically, garbage collect, is run automatically as I run lots of other things. And it says, hey, if you have anything to do, then you can definitely do what you need to. But the majority of the time, it's a no-op and it does nothing. Git gc will go through our tree, finding all of those dangling nodes that don't have any branches pointing at them, and remove them if they're old enough. And also, it will come in here and pack all of these files into this pack file. Here's the pack file, and here's the index. So we still have all of our content. We just don't have it spread out in all of these folders anymore. We're kind of done with it. And so zlib compressed all of those commits and trees and nodes together. But if we come back into our visualization, we still have all of those nodes in spite of the fact that they are packed inside the pack file. That's cool. So we see that we have commits, we have trees, we have blobs. That's cool. We've pretty well beat up this objects folder. Next up, let's look at the refs folder. Now in this case, we don't have any. Let's go play with this. Git log --1 line. I'm going to git checkout file 2 right here. Now it tells me that I am in a detached head state. So like I take my head off? Is this a zombie scenario where we kind of have Git in this weird state? Well, the interesting thing is, let's pop open that .git folder and let's look at head. The head file points to where head points at, and right now it says it's a commit. Now we learned when git gc runs, it may prune nodes that are old enough and not referenced by a branch. Well, that's what we mean when we're in a detached head state. Our head is not pointing at a branch. Well, let's do that. Let's say git checkout or git branch new branch and git checkout new branch. Now when we do git log --1 line, now we will see that head points at new branch. Let's pop open that head folder, and we see that head points at refs, heads, new branch. Cool. Refs, heads, new branch. Nice. Now, new branch points at this particular commit, 0D2175. 0D2175. That's the commit that the branch points at, and head points at the branch. Git checkout main echo file5 to file5.txt, git add file5, git commit -m file5. Now if we pop open the head, we see that head points at main, and now we have a main branch that points at that new commit. Why didn't we have a main before? Well, it got packed in the pack file. And so, well, we didn't need all these dangling files. What's cool is that these refs are just points to a commit. That's cool. So if I wanted to, I could say, right now this, actually git log --one line --graph --decorate --all. Now we'll see all the things. Here's new branch, git checkout new branch, git log --one line --graph --decorate --all. Now we see head is pointing at new branch, and new branch is over here. Well, we could say I would like head to point not to refs head's new branch, but refs head's main. And if we do this again, we can see, okay, head is now main. It's just a reference to that file. For git status, we kind of destroyed the directory. Let's put that back. So say that, well, I don't really want new branch to point to it. I want it to point to that. And if we do this git log one line, now we see new branch. We definitely don't want to do that as well. That will kind of mess up our history. We really want branches to be where they are. That's cool, but these files are just text files pointing at the nodes where these branches exist. How about tags? Git checkout main, git tag 1.0, log --one line --decorate all. See, we have a tag here. And if we come back into our .git folder and we open up tags, here's this 1.0, and it just points at that commit as well. Perfect. Refs are just text files that point to the commit that they reference, and head is just a text file that points at where does head point to. If we're in a detached head state, that means that head doesn't point to a ref, but rather points to a commit. In which case, if git gc runs, we may lose access to that commit. That's cool. Well, let's create a new server repository. How does servers work here? Here's a server folder. And so let's go into this server folder. And this server folder is empty. Let's create a new Git repository here, git init. But instead of just git init, I'm going to say --bear. Now, a bear repository is no different than a regular repository, except for it's only the contents of the .git folder. It doesn't have a working directory. Okay, now that we have this server, we can go look at, go back to our regular repository. Let's git remote add origin. There's nothing magic about the name origin. We could have said foo, but let's say add origin, and we'll give it a URL to that origin server. Perfect. Now let's git push origin main. We're now sending our up to that bear repository. If we go look at log --one line --graph --decorate all, we can see that we have this origin main branch. Where does origin main live? Let's go look inside the refs folder. And if we refresh this, we now see that we have remotes. Now inside remote, the origin folder, and inside origin, we have main. This is where we believe the remote server's main is. It's just when it references this git hash. If we pull and push, then it would update this file. We could create another git remote add foo, and we'll a path to that server, git log one line dash dash graph dash dash. We haven't pushed anything to the foo server, but we could say push origin, no, git foo main, and now git log dash dash one line dash dash graph. Now we have a foo main folder too. Back in our pardon me. Back in our remotes folder, we now have origin and we have foo, and foo main points here. That's great. Okay, let's check out new branch, and we'll do some more commits. Echo file 5 to file 5, txt, git add file 5, git commit -m file 5. Now we know that we're going to get a commit node, a tree node, a block node. We know that we'll update the ref for new branch, dash dash one line dash dash graph dash dash decorate dash dash all. We'll update this to point to this new commit here. Git checkout main. Git branch dash d new branch. I got excited. I deleted this, and now if I look at my history, I don't have that new branch anymore. Did I lose my commit? Well, if we come back here into our visualization tool, let's refresh this. Yes, I'd like to look at parent-child. Let's show the type, show the lines, show the tags. I still have this new branch commit. I just don't have a branch pointing to it. But I can get back to it. I know what that commit message is. That's cool. I could just say git checkout that commit. Well, how do I know where that commit is? Here's a really cool tool, git reflog. I've also heard it called reflog. The reflog. Where have the refs been recently? Where is that stored? Here inside the logs folder. Now, in this case, we're looking at the head log. And so we can see that it was here and it moved to there. Before that, it was here and it moved to there. Before that, it was here and it moved to there. And we can also look at the logs for various remotes. Here's the main branch and where we were on the main branch. From here to here. From here to here. So using this ref log, we can see that, oh, we had this 0CE6D5 git checkout that. We're in a detached head state. We know that our head is pointing at a commit, not a branch. Git checkout -b new branch. Git log -- one line -- graph -- decorate -- all, and we're back. Now we can do this using the logs if git gc hasn't run recently, and if we do it within the default is 2 weeks of finding that we've abandoned that commit. Reflog can be really powerful, and this refs folder is that mechanism of browsing through those reflogs. That's cool. Next up, let's look at, so we looked at refs, we looked at objects, we looked at logs. Let's look at hooks. Now here in the hooks folder, I'm going to close these. Here in the hooks folder, we have scripts. Now that's a bash script. Here's another, shell script. Here's a Perl program. Here's another shell script. These just talk about mechanisms that we can do when these Git events happen. Now right now they're .sample, so they're not actually run. But let's go rename these to not be .sample, but rather just to be their regular names. Okay, set those in place here in this folder. And so basically I just removed the .sample part. And now we have files. In this case, I'm just echoing that this event happened. In each one, I'll just echo that this event happened and echo the command line arguments passed to me. That's cool. So let's take these Git hooks out for a spin. These will happen at various events when we do Git operations. So echo file 6 into file 6.txt, git add file 6, Git add file6.txt. No hooks yet. Git commit -m file6. Now we got a hook, the pre-commit hook, the prepare commit message hook, where we get the commit message, and then we've got that final piece. That's really cool. If we wanted to, for example, validate the commit message or validate the files that we're committing, we could do that in that shell script. Git push origin main. Nope, we're on new branch. New branch. Now we see that we've got a pre-push hook and a bunch of content. We could validate, we could run our unit tests, or we could validate that the content is in a usable state. Now, we've created all of these hooks that we want to commit, git status. They're not part of our repository. Yes, we can't commit this .git folder, so we kind of want to move our hooks folder somewhere else. Except for, well, then how do we hook into these hooks? There's a node package, and there's packages in other languages as well. This node package called git hooks is a really elegant way to be able to set those hooks in a different folder. So as it installs this git hooks project, it will actually create a new folder that we can commit to our source control repository, and then create symlinks or calls out to that other folder. So now, as soon as I npm install, I get all my hooks, and I can now share them with my team. That's great. Hooks are a great way for us to be able to run extra processes. Maybe it's linting, maybe it's running unit tests, maybe it's validating that our commit message is in the right format to hit our release notes. That's hooks. It allows us to do some really elegant automation. Let's next look at configuration. Here's this config file. Now, this config file references our remotes, where's the URL, both to fetch and to push. It shows us some things, repository format version, file mode. In this case, I'm ignoring case. Now, this config file, specific to this repository, will override the commit file in my local directory. So in my profile directory. So cusers rob.gitconfig. Here's the git config that I have in my user home directory. Now it specifies more things. It specifies some aliases that I have, some diff tools that I've set, and it also sets my user name and email, but also my GitHub username. Oh, that's cool. Because my local repository overrides this profile that I have set, if I want to, for example, work on a work project instead of a personal project, I can change this to bigco.com. And now I'm using the email alias, the email for my work project instead of my home project. That's cool. I've just overridden this. Now this .git config in my user profile actually overrides the details in the git config installed with Git. This one happens to be in program files git etc git config. If I installed this on a different operating system, it would, but it's buried in the details of Git. Now this explains the things, for the most part, that I chose when I installed Git. Auto carriage return line feed is true. Yes, I said I wanted that option. Rebase is false. I'm using a credential helper in this case. And in this case, I chose to set my default branch name to main instead of master. Black Lives Matter, and it's really important for us to not use discriminatory technology. And so I've chosen discriminatory words. I've chosen to modify my system to make my system use the default branch name of main. Now, if I'm in a repository where I need to do this, this one may call it trunk, I can make that default branch be specific to whatever repository I need it to be. I love that these configuration values, the one specific to my repository, and then layered on top of the one in my home directory, layered on top of the one in my Git install directory. If I picked any weird options that I need to have in a particular repository or in my user profile that I don't want to have to remember when I run the installer next time, I can promote those to the next level up. And if I need a specific thing in this repository, I can put it here in this config file as well. These config files are really helpful. Let's look at another config file. Here in info, there is an exclude file. Now this would have the same format as a .gitignore, bin obj, .vs, node, modules, but this one is in a place where I can't commit it. Git status, we see that, nope, we can't commit this. This is a great way to be able to specify ignore files, but I would argue the .gitignore file is much better for this. The exclude file is interesting. Okay, so some more configuration. The description file. If we're using Git InstaWeb, a web server for Git to be able to view things, then this is the description of that repository. That's really cool. And then index. Here's another configuration file. Now this is a binary file, and it's kind of a mess. If we were to look through this, there is a program here called Gin that is able to parse this index file. And here's a great Stack Overflow post that talks exactly about how this index file is built. Yeah, the takeaway that I got as well is git ls files stage is actually a better way to browse it. Git ls files stage. Here it lists all of the files in my working directory. Now this is a really cool cache where it knows exactly what's the blob ID of each of the files in my working directory so that Git can do really fast operations to validate, did my blob change between the working directory and the one that it has stored in its repository? This 0 represents the stage that it's in. By default, all things are 0. If we're in the middle of a merge, then they'll use 1 through 3 to represent mine, yours, and our base version. But for the most part, you'll see zeros here. But that's all of the files that Git knows about in my working directory. So as I commit new files, it will update this index file so that it can do operations really quickly on my behalf. That's cool. Temp files. There's a bunch of temp files inside Git, and we can wander through them. Here's commit edit message, and this is the edit message. This is the commit message of the last commit that I did. As it passes content through hooks, it's going to use this commit edit message to be able to do that. We might also find a commit message here. Orange head might appear here. That is the spot where head used to be. And info refs is another temp spot where it's talking about refs head's main points here. A temp file. What we found was we've got hooks, logs, objects, refs, indexes, temp files, configuration. These are the various types of files that we have in Git, and we were able to look through each of them. Here's a great article about what's inside your .git directory. I will paste this in chat as well. And this is a great way to be able to wander through all of the pieces. If you want to continue this discussion, here's each of those files and the purpose that they serve. Git is a really elegant system, and as we start to understand some of the pieces behind Git, we can get a feel for how this works. It's a really elegant system. I'm really grateful that I get to present here in Greece. Thank you for letting me share Git with you. For those watching this video later, you can hit me up on Twitter at Rob_Rich. For those people who are here live in the conference, what are your questions about Git? Ooh, thank yous. Yes, I had so much fun presenting this. If you'd like to see this presentation or others in your user group or your conference, hit me up on Twitter or by email. I would love to present this again. Thanks, everyone. I'll see you in the next session.